Now the fifth property of greatest integer function is the value of greatest integer function of x will lie between x minus 1 and x. We know that any x is greatest integer function of x plus f, and this f, it belongs to 0 and 1. So it is greatest integer function of x plus some value. So its maximum value will be simply x, and x minus 1 will always be less than greatest integer function value. Now we use this property while solving limits. Say for example, we have this question which is limit n tends to infinite, greatest integer function of 1 square x plus 2 square x up to n square x divided by n cube. So what we know is, because this n tends to infinite, it is infinity upon infinity form. Now any greatest integer function of x, it will lie between x minus 1 and x. So I can write 1 square x will lie between 1 square x minus 1 and 1 square x. In the same way, 2 square x will lie between 2 square x and 2 square x minus 1. 3 square x will lie between 3 square x and 3 square x minus 1, and this series will continue up to n, that is n square x minus 1, get a function of n square x, and this is n square x. If I add them all up, I can write it as 1 square plus 2 square, it goes up to n square into x, and then minus 1 minus 1 minus 1 n times, so there will be minus n, and this is less than greatest function of 1 square x, get a function of 2 square x, get a function of n square x, and it will be less than or equal to 1 square plus 2 square up to n square into x. Now for this limit, I'll need to divide it with n cube. So I'll divide each of the three expressions with n cube. And I'll also take this limit n tends to infinite for all the three expressions. Limit n tends to infinite. Here also I'll take limit n tends to infinite. And here also I'll take limit n tends to infinite. Now 1 square, 2 square up to n square. This is nothing but limit n tends to infinite. This is n plus 1 to n plus 1 by 6 into x, and then minus n whole divided by n cube. Here it will be simply, so I'm not going to solve this limit. So I'll simply write it as 1 square x up to n square x upon n cube, and this is again n plus 1 to n plus 1 by 6n cube into x, and this is limit n tends to infinite. Now it's an infinite limit. Now in infinite limit, if the degree of numerator and denominator is same, so the degree of numerator is 3 and the degree of denominator is also 3. So answer to this limit simply will be the leading coefficient of n cube in the numerator, which is 2 by 6 x, and leading coefficient of n cube in the denominator, which is 1. And in this case also, it is a polynomial of degree 3 in the numerator, and here also degree in the denominator of n is 3. So again in this case, it will be 2 by 6, which is 1 by 3 x. Both these limits on the left hand side and also on the right hand side, the value of both the limits is 1 by 3 x. Sandwich theorem or squeeze play theorem says, if we have a function fx which lies between f1x and f2x, and if I take limit x tends to a, f1x if the value of this limit is L and the value of second limit is also L, then in that case, the limit of this function x tends to a fx will also be L. So from sandwich theorem, we can say that the value of this limit will also be 1 by 3 x. We use this property while solving the problems in limits.
If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist, and select the topic you wish to study.